Over the last several centuries, there have been many unsolved questions that scientists have put their minds to solving. Most of them were eventually resolved. However, there are some questions that are still outstanding, and we really aren't any closer to solving them than we were before. Learn more about dark energy and dark matter on this episode of Everything Everywhere Daily. This episode is brought to you by the Travel Photography Academy. Have you ever been on a trip and wondered why your photos don't turn out like the images you see in travel magazines? If you're going to spend thousands of dollars on a trip and hundreds to thousands of dollars on a camera, you owe it to yourself to get the highest quality images from your trip. That's why I created the Travel Photography Academy. I set out to travel around the world in 2007 with an expensive camera, and I had no idea how to use it. As I traveled around the world, I taught myself the art of travel photography, eventually mastering it to a point where I was named Travel Photographer of the Year 3 times in North America. The Travel Photography Academy is an online course that teaches you everything you need to know to master your camera and to take better photos on your next trip. To improve your photography and to get better images on your next trip, visit travelphotographyacademy.com or click in the link in the show notes. What is dark matter? We don't know. Honestly, no one can say that they really have any clue. There are a lot of theories and hypotheses floating around about what it might be, but so far nothing has panned out. It's the biggest outstanding mystery in physics today. So the real question shouldn't be, what is dark matter? The real question, for the purposes of a podcast like this one, is how do we even know that such a thing exists? What leads us to believe that there's such a thing as dark matter and dark energy in the first place? First of all, let's set the groundwork with the physics we know. When a satellite orbits the Earth, or a planet orbits the Sun, we have a really good handle on how that works. The further away an object is from the center, the slower it moves. In our own solar system, each planet further from the Sun moves slower than the planets before it. To show the extremes, Mercury travels at a speed of about 107,000 miles per hour, whereas Pluto, which is not actually a planet, and I did an entire episode on that, travels at a slow 10,700 miles per hour. The same rules apply to satellites that travel around the Earth or to the moons of Jupiter. Just as moons orbit planets and planets orbit stars, so too do stars orbit the center of a galaxy. And here's the other thing. Astrophysicists have a pretty good idea as to how stars work. We've cataloged over 84 million stars already. We can classify stars by their mass, and it's possible to know how much the total mass of stars is. The problem is this. Stars orbiting around the center of a galaxy do not exhibit the same behavior as what we see with other orbital bodies. Stars going around the center of a galaxy do not behave like planets orbiting around a star. The stars further out are going faster than they should be, and this doesn't make any sense. Something has to be providing the gravitation to make this happen, and we don't know what it is and we can't see it. Hence, it's called dark matter. The problem was identified well over 100 years ago. And at its core, the problem is one of addition. Things just don't add up. In 1884, well before we even knew about galaxies outside of our own, Lord Kelvin made an observation that the velocities of stars going around the center of the Milky Way didn't match up with the mass of the stars we can see in our galaxy. Kelvin hypothesized that there must be something out there that we can't see, which is responsible for the increased velocity. The term dark matter was first used in 1906 by French mathematician and physicist Henri Poincaré. Over the decades, the evidence that there's something out there that we can't see that's influencing gravity has kept piling up. Gravity can bend light like a lens, and there's an effect called gravitational lensing. In the measurements which have been taken, light is bent due to much more gravity than there should be. Cosmic microwave background radiation points to the same thing, as do the formation of galactic clusters and other observations. As instruments, techniques, and computational power have improved over time, the evidence has kept piling up. The current estimate is that the matter we can see only makes up about 15% of all matter, and the other 85% is dark matter. So the stuff we can't see is like most of the stuff. So if we don't know what it is, what are some of the theories as to what it could be? One theory is that it might be something called WIMPs, or weakly interactive massive particles. These could be particles like neutrinos or some other unknown subatomic particle that doesn't really interact with normal matter, but still has some effect on gravity. Neutrinos, for example, are everywhere. In just the time it took me to read the last sentence, Trillions of neutrinos passed right through your body and through the Earth. They just passed through almost everything as if it were a ghost. They are insanely hard to detect, but they have been detected. However, nothing about our knowledge of them would make up for all the gravity that we're seeing. There are other theoretical particles called gravitons or axions which have been proposed as well. There are researchers working on this line of attack, but so far no dice. Another theory, which is a counterpoint to WIMPs, is something called MACHOs, or Massive Astrophysical Compact Halo Objects. And you really have to love astrophysicists' ability to come up with acronyms. This would just be regular old matter, but stuff that doesn't emit light that we can't see. This could be brown dwarfs, think an even larger version of Jupiter, neutron stars, black holes, or other stuff that we just don't know, but it doesn't emit radiation. The problem with this is that the things like dust clouds still emit infrared radiation that it is absorbed from other sources, and there can be emissions from things surrounding a black hole. Also, if there were more heavy elements, it wouldn't really fit with what we know about star formation and the creation of elements. Machos are probably the least likely candidate at this point. One other possibility is that dark matter doesn't really exist at all. Maybe our understanding of gravity is just wrong. Just like Einstein improved upon Newton's gravitational theories, perhaps what we know from Einstein needs some improvement as well. There have been several proposed new ideas on what gravity is, which would also try to bridge the gap between gravity and quantum physics, which is the other big outstanding mystery in physics. However, these haven't really been proven or adopted by the wider physics community. Okay, well then, what about this dark energy thing? I mentioned that before as well. What's the deal with that? Well, as with dark matter, dark energy is an attempt to understand something which has been observed but hasn't been explained. Astrophysicists have long known that the universe was expanding. However, the assumption has always been that the expansion would eventually slow down and maybe even reverse due to gravity. However, in 1998, researchers found something astonishing. Not only was the expansion of the universe not slowing down, but it was accelerating. For something to accelerate, there needs to be a force or energy behind it. This mysterious energy has been dubbed dark energy, because no one knows what it is. Here, too, attempts to solve the puzzle have been for naught so far. There are theories that this is just an intrinsic part of space. Some hold that this is an interaction with dark matter, or it has something to do with dark matter, thus trying to solve both puzzles at once. Others hold that there's some sort of anti-gravity force that only works at very vast distances. Yet others have postulated that dark energy is really just a case of poor measurement. It might not actually exist at all. That the data was really just an artifact of something else which makes it appear to be accelerating. For both dark matter and dark energy, we are left with a great big, we don't know. If our observations are correct, then when you combine both dark energy and dark matter, over 95% of our universe consists of matter or energy that we can't observe. Most of the advances on this topic have been in determining what dark matter and dark energy are not more than what they actually are. And that may not sound like progress, but it is. As Sherlock Holmes noted, when you've eliminated everything else, whatever is left has to be right. So, lest you think we have it all figured out, there are still major mysteries out there that science hasn't figured out. And in this case, the mysteries just might make up the vast majority of our universe. Executive producer of Everything Everywhere Daily is James Makala. The associate producer is Thor Thompson. Remember to leave a 5-star review to get your review read on the show. They can be left at Apple Podcasts, Podcast Republic, or wherever you listen to the show. Also, you can help support the show over at Patreon.com. Patrons can get merchandise like t-shirts and hoodies, as well as having direct access to provide suggestions for future episodes.